Hello everyone, let's provide a solution given this nice algebra problem, which is m cubed plus 5m, this is equal to 42. So what is the value of m? Now, we have m to power 3 plus 5m, this is equal to 42. In this case, let's take 42 on the left-hand side, so that now we'll have m to power 3 plus 5m subtract 42, this is equal to 0. Now from here, we can express 42 as 27 plus 15. Now given this, we'll have m to power 3 plus 5m subtract. Now this 42 we can express as 27 plus 15. This is equal to 0. Now the next phase here, we'll have m to power 3 plus 5m subtract 27 subtract 15. This is equal to 0. Now from here, we can express 27 as 3 to power 3. Now we'll have m to power 3, okay? Subtract 27, which is 3 to power 3, plus 5m subtract 15. This is equal to 0. So from here, we have m to power 3, subtract 3 to power 3, plus, now we have 5m, okay? Subtract, this is actually 15 can be expressed as 5 times 3, which is equal to 0. Now the next step here, you find that the first part here, this is actually the difference of two cubes expressed as a cubed minus b cubed. And here, we have that 5 is common here. So that means this is the same thing as m to power 3, subtract 3 to power 3, plus 5 is common, so we can factor out 5, so that we'll have m subtract 3, and this is equal to 0. So we have m cubed minus 3 cubed. So applying this, the difference of 2 cubed, that is a cubed minus b cubed, which is essentially a subtract b. This is a squared, okay, plus ab plus b squared. So let's proceed from here. Now applying this identity, m cubed minus 3 cubed, m cubed minus 3 cubed, this becomes m subtract 3. Now here we'll have m squared plus 3m plus 3 squared, which is equal to 9. Okay, so now given this, we'll have m subtract 3, close the bracket, then we'll have m squared plus 3m plus 9. Then now we add 5, okay, m minus 3, this is equal to 0. Now the next step here, you find that m minus 3 here is common, so we factor out m minus 3. So we'll have m to power 2 plus 3m plus 9 plus 5. This is equal to 0. So in this case, we have two parts here. We have m minus 3. This is equal to 0 as the first part. And the second part, we have m to power 2 plus 3m. Then 9 plus 5, this is actually 14. This is equal to 0. Now in the first part here, you find that m1, this is equal to 3. Okay, this is the first solution. And the second part here is a quadratic equation of the form am squared plus bm plus c, this is equal to 0. So the first thing to do here, let us assess the discriminant value so that we can check the nature of the root of this quadratic equation, which is b squared subtract 4ac. So in this case, we'll have b here from the quadratic equation. We have a equal to 1, b equal to 3, and c equal to 14. So b squared is 3 squared, subtract 4 times A, which is 1, times C, which is 14. Now, the next phase here, we'll have 3 squared, which is basically 9, subtract 14, 14 times 4, which is essentially equal to 56. Okay, now the next step here, we have 9 subtract 56, and this is actually negative 47, which is less than 0. So this means that we have two complex roots. We have two complex roots here. We have two complex roots here, which we can solve. That is M2 and M3 can be solved by applying the quadratic formula, which is minus b plus or minus the square root of b squared minus 4ac, all this divided by 2 times a. So in the next step here, we'll have minus b, which is negative 3, plus or minus the square root of b squared minus 4ac, which is the discriminant value here. This is negative 47. All this divided by 2. Okay, so now we'll have here negative 3 plus or minus the square root of, we can express negative 47 as 47 times negative 1 divided by 2. And here we'll have negative 3. This is negative 3 plus or minus the square root of, now we have 47 times negative 1 divided by 2. Now we'll have negative 3 plus or minus the square root of negative 1. This is I square root of 47 divided by 2. So in this case, we have two complex roots. That is M2. This is equal to negative 3 plus I square root of 47 divided by 2. And we have M3, which is negative 3, subtract I square root of 47, all this divided by 2. Now, that means that we have two complex roots here, and we have only one real solution, which is M1, which is basically equal to 3, which is equal to 3. So we are seeing that we have three solutions, two complex roots, okay? That is M2 and M3, okay? That is M2 and M3. And we have only one real solution, which is 3. So let's verify that 3 actually satisfies the equation. So if you recall, we end that m to power 3 plus 5m, this should give us a value of 42. So substituting the value of m, we'll have 3 to power 3 plus 5 times m, which is 3. This should give us a value of 42. So here, 3 to power 3, this is 27, plus 5 times 3, which is 15. This should give us a value of 42. So 27 plus 15, this is actually 42. Okay, and that means that the left-hand side is equal to the right-hand side. And that affirms that M1 actually satisfies the equation. Okay, so kindly follow the steps, like this video and subscribe.